Hey guys, welcome back. We're going to start our last unit that we're going to do before Christmas. So there's only 5 lessons, I believe, to this one. I might add a 6th, just depending on how things go. While you're here, I might as well warn you. There's a good chance if we don't come back in person that I'll change our grading scale from where right now it's like 30% of your grade is homework to probably more like 60 or 70% of your grade will be based on homework. So make sure that you've turned in and submitted all of your homework and that's completed, because basically the difference between you passing and failing the class would be whether or not you've done all of your homework. So if the grades do become less weighted towards the test because we're not able to do them in person and more weighted towards the homework, it's going to be vital that you guys have all of your homework turned in. So that being said, you can turn in any late work for me for full credit. So just make sure if you have any incomplete assignments or assignments that haven't been turned in, just go back and make sure that you get that done. So you've got basically the last 5 weeks or whatever before the semester is over for you to get all of your homework turned in, and then we'll worry about these last 5 assignments as well. So probably post something, make sure everyone gets that information on Google Classroom. But let's go ahead and get right into it. So this is our last unit that we're going to do before Christmas over congruency. There's going to be quite a lot of stuff that we're going to be bringing up through here with some proofs, but just kind of roll with it, and I think you'll do all right. So let's start out with the triangle interior angles. So if we have a triangle, do you remember what the angles add up to in a triangle? You probably do. They add up to 180 degrees. So if you think of an equilateral triangle, for example, let me see if I can draw one of those real quick. So equilateral triangle, remember all 3 of those angles are 60 degrees. And so therefore 60, 60, and 60 is going to be 180 degrees, right? All right, so that's just an example, but not a proof. So we can actually give a proof by that by taking a line that's parallel to the base of a triangle, putting it through the 3rd point, which would be this angle B up here. And then if you realize these 2 lines are parallel, then we know A is going to be alternate interior with this angle right up here, right? So alternate interior angles are congruent. It's one of those kind of things that we need to remember, right? C is also alternate interior to this angle up here. And then you'll probably notice that all three of these angles together are going to add up to 180 degrees. So angles A, B, and C together are going to add up to 180 degrees. All right, there we go. Now you can show this with any triangle. So if we take our angles here, we still have alternate interior angles A, B, and C here. If we have this funky triangle here, still alternate interior angles A, B, and C, they're still going to add up to 180 degrees. So kind of cool. All right, then we have the symbol congruency. Now, we've actually already talked about this before, but the symbol is broken down into 2 parts. The first part is a tilde, like the tilde used in Spanish for nasalization as in señor. Terrible Spanish, I'm sorry. And then the equal sign, which means it has the same size. So the tilde tells us it's the same shape, which also means it's similar, by the way. And then the equal sign means it has the same size. So for 2 geometric figures to be exactly the same figure and the exact same size, that would mean that they would be congruent to each other. That's why we can have segments that are congruent. They have the same length, but they're also both segments, so they also have the same shape, right? Triangles can be congruent, in fact, as well, if they're the same shape, same right triangle, for instance, with the same angles, and they're also the same size given by the same side lengths as well. But we'll get into that with more detail later. So if we look at these 2 triangles here, you notice that they're both right triangles, okay? We also will probably notice that these angles in the middle are going to be exactly the same as well. Do you remember why these angles are the same? What kind of angles those are? Those are vertical angles. So that's another one you're going to need to remember. So vertical angles are congruent. So they have 2 of the same angles. And so if 2 of the angles are the same and they have to add up to 360 or 180 degrees, right? That means that the 3rd angle is going to be congruent as well. So these 3rd angles are also the same. That's called the 3rd angles theorem. So the angles in the middle, they were congruent because they're vertical. And then if we have 2 angles are congruent, that means the supplement of those 2 angles, the remaining 180, is going to be congruent by the 3rd angles theorem. Okay, so lots of theorems we're using. Vertical angles, 3rd angles theorem, some of the interior angles of a triangle, lots of good stuff. But we're going to be using the same things over and over again for this unit. So just keep going through the videos. I'll repeat it over and over again and in the homework. So don't worry, you'll pick up on it. All right, so if all the angles are the same, that means that it's going to be the exact same shape. That comes from the angles. So if the angles are the same, that means it's the same shape. So it's the same right triangle with the same angles. But are these necessarily the same size right triangles? No, clearly this one is smaller than this one, right? So the size actually comes not from the angles, but it comes from the sides, okay? So if the sides are the same length, then it's going to be the same size. If the shape is the same, then that's going to be coming from the angles themselves. Okay, so what we can actually observe on this one, let me kind of clear, in fact, I'm going to clear all the text here. Boom, isn't that lovely? Love the smartboard. Is if I change this line here, you'll notice that the angles are still vertical. The third angles are still going to be congruent. So these two triangles are still going to be similar to each other, but they're not necessarily congruent until we pass through this point here, which would be the midpoint. Once we hit that midpoint, it's going to cut this segment in half. These angles are still vertical. The hypotenuses are going to be the same length as well, and the other legs are the same. And we also know, I guess I should put 3 marks through both of those. And we also know that the third angles are going to be the same as well. Once we know all that information, we can say that these two triangles are congruent to each other, and then we can write a congruency statement at the end, which we'll do in just a second. So they're congruent because they have all the same angles are congruent, the corresponding angles are congruent, and the corresponding sides are congruent as well. All right, so kind of cool. We've got similarity, which is when only the shape is the same, but not the same size. And then we have congruency, which is when the same size and the same shape, meaning the angles are all congruent and the sides are all congruent as well. Really good topic here. All right, so how do we test for congruency? Well, we test it with superposition. So superposition is a property in geometry where we're allowed to move shapes in space and in time, I suppose, and they retain their properties. So a triangle on the whiteboard is the same as a triangle on your screen, which is the same as a triangle on my screen. They don't change their properties just because they move their locations. So it allows us to move things in space and retain their properties. So for instance, if I wanted to test to see if these two triangles were congruent, they look like they're the same, one thing that I could do is I could rotate it upside down. It's still the same triangle, right? Even though it's upside down. Still has the same angles and the same sides. Yeah, we're fine. And then I could translate it up here. I don't remember our translations. And they coincide, exactly, right? The vertices are in the same locations. All 3 angles are the same. All 3 side lengths are the same as well. So then what does that tell me about these two triangles? Triangle ABC and triangle FED. Well, if they have the same angles and they have the same sides, then they're going to be congruent. Now, unfortunately, we can't move things on your paper to see if they coincide, to see if the vertices match up and stuff like that. But theoretically speaking, we can use superposition, which is like geometry superpower, to move things in time and space to be able to figure out if they are actually indeed congruent, if all their parts coincide. So now that we know that they are congruent, and again, I could show that to you again by flipping this one upside down and then moving it over here. Okay, yeah, they're exactly congruent. I'm actually going to leave this one over here just so you can see it for reference. So since they are congruent, now we want to write something called a congruency statement. Now, a congruency statement is very important, the order that you write it in. So triangle ABC is congruent to the other triangle, but the order that we say these vertices is very important. So is triangle ABC congruent to triangle DEF or EFD or FDE or FED? The order is very, very important. So we need to make sure that the corresponding parts that are congruent are matching up. So if we started out with angle A, that's going to be the skinniest, the smallest angle because it's opposite the smallest side. That's a triangle inequality theorem. I know, another theorem, right? Then the longest angle is opposite the longest side, right? Our right angle is the biggest angle, so it's opposite the hypotenuse, which is the longest side. And then our medium angle is opposite the medium length of the side. Again, triangle inequality theorem. It's good stuff. Anyway, so our smallest angle opposite the smallest side is A. That's going to correspond with the smallest side and the smallest angle, which is D. So A is going to go with D. You see that? Okay, so I'm color coding so you can see them as well. So this would be red, just like that one. And then B, which is our right angle, is going to go with our right angle here, which is point E. And then the only thing that's left over, of course, has to be C, goes with the F, right? Okay, so moving that out of the way, or just making it on top. You see that ABC, so triangle ABC corresponds with triangle DEF. And if I overlay them, you'll see exactly what I was talking about, right? So triangle ABC is congruent to triangle DEF. And notice all the parts are matching up. All the vertices match up in the same order. That also means we can break it down into side lengths here, and I will really quick. So side AB, the first two, is going to be congruent to side DEF. the first two as well. So AB is congruent to side DE. Sure enough, they are. Okay. The last two BC, B and C, correspond with the last two of E and F. Good. And the first and last, A and C, is going to correspond with D and F. Okay. Good stuff. All right, so parts of congruent triangles. So as we said here, looking at the congruency statement, we can fill in the other parts. So if I know that AB is 8, so AB is the first and the first two, that means DE, the first two, also has to be a length of 8. So this is 8, sure enough. Okay. Then I know BC is 6, which is the last two. So the last two, EF, has to be 6 as well, and it will be. The angle C, which is the last one, goes with the last angle F, which is also going to be 53, so we're good. And then angle A is 37, so that's going to go with angle D, the first one over here, which is also 37. The only one we haven't done is FD, which is DF, the first and last, which goes with AC, the first and last, which is AC is 10, the longest side of 10. All right, so that's basically how we use corresponding parts of congruent triangles are congruent, which we'll talk about later. So all the corresponding sides, so 6, 8, and 10, the corresponding sides of congruent triangles are congruent. The corresponding angles as well, like the 37, the 90, and the 57, 37, 90, and 53, sorry, dyslexia, those are also going to be congruent. Okay, so all the corresponding parts of congruent triangles are congruent. The corresponding sides are congruent, and the corresponding angles are also congruent. It's that simple. And all that information, by the way, is given to us by this in this congruency statement. All right, so let's write another congruency statement here. So these are congruent as they appear. Let's look at our shortest side, or our longest side here, which is AB, the first two. Well, this A is going to be our smallest angle, right? So that's going to correspond with our smallest angle over here, which is E, okay? And then the next one is our right angle of B. So that's going on the longest side. AB is the longest side, so EF is the longest side over here, so EF. And then you can probably guess the next one. So we're going around, so A, B, C, D, E, F, G, H. We're just going in a circle at that point. You can finish it off. Cool, there's our congruency statement, and all the parts are going to be lining up. So angle H is our biggest angle here. It's going to correspond with angle D, our biggest angle over there. All right, same thing, color code this time. Let's see if we can move some parts around here. So angle A is the first one, goes with angle E. So if this is 37, the corresponding part, angle E, has to be 37. It is. All right, and then GH is the last two. That's going to go with CD, the last two, which is 10. So this has to be 10, and it is. BC is the middle two. That goes with FG, the middle two, or GF as well. Good to go. AB is the first two. Goes with EF, the first two, which is 12, the longest side, which would be 12 there. All right, good to go. All right, the only other thing we need to know, and they'll be important on our next lesson with side, angle, side, is what does it mean to be an included angle or an included side? So included is just a fancy way of saying in between. So if we want to know what angle is included in between two sides, it's going to be the angle that's directly in between the two sides. So what angle is included between sides AB and AC? So AB is this side here, AC is this side here, right? So the angle that's included in between those two sides is going to be angle A. So angle A is included in between those two. Now, another way that we can actually see this, oh, did I not do it? Yeah, I guess it's right here. Is it's the part that's going to be repeated. So the angle that's between AB and AC is going to be angle A. So AB and AC, what's in between those two sides is angle A. Now, where this comes into play is when we write it, where we have this side here, and this included angle in between it. So we're going to use side, angle, side, where the angle is included in between those two sides. And we're going to write it like this, okay? So I'm just letting you know the one that's in between, included in between the two sides, is going to be the angle that's directly in between the two. So we're not using angle B. That would be ASS, which is also the donkey postulate, just in case you're wondering. But we're going to wait on that one because that's a fun one. Fun day. What in the world just happened? Okay, clear all text. Moving on. All right, so what angles include between ZY and XY? Well, it's the one that's repeated. It's got to be Y, right? So ZY and XY. Okay, so clearly Y is going to be the angle included between those two. So we have the side ZY and the side XY, and the angle that's included in between those two is going to be the angle Y. And this would be, again, using side, angle, side, where the angle is included in between those two sides. All right, what about included sides? So included sides are in between two angles. So what side is included or in between the angles A and C? Well, that's clearly going to be the side AC, is it directly in between those two angles. So here we're proving it with angle, side, angle, where the side is included in between the two angles. So we have this angle here, and then we have the side that's included directly in between those two. All right, included by y and x. All right, x and y. So clearly xy is going to be the one that's included in between those two. And there's those in case you're wondering. And so on this one, we just kind of combine the two angles to get the side that's in between the two. So anyway, no big deal. All right, so that was it. 15 minutes, not too bad considering there's quite a bit of new stuff there. So do make sure that you're watching these videos. If you just skip to this answer, shame on you, because there's new stuff and there's no way you're going to learn the stuff just by doing the homework. Okay, my homework's not that great. All right, so look at number 1, part A. Which angle is congruent to angle U? So on this one, I don't think I gave you a congruency statement. I didn't give you a congruency statement, but all the sides and angles are marked with their tick marks. So if you look at U, angle U has 2 marks. So which one over here has 2 marks? X. So that would be angle X. Angle T has 1 mark, so that goes with Y with 1 mark. V has 3 marks, so that goes with angle W. All right, which side is congruent to TU? TU is 1. 1 mark would be Y and X. Now, the order on this one doesn't matter, but if I am starting with T, I'm going to start with Y because those two we said were going to be corresponding angles. So TU goes with T or YX. You could also say XY, but let's go ahead and get in the habit of making those in the same order. Then TV is going to be the hypotenuse starting at 1 going to 3. 1 to 3 here would be YW. Okay, just talking about the angles. And then UV, going from the 2 angle to the 3 angle, is going to be XW from the 2 angle to the 3 angle. So that would be XW. Now, the reason we want to do that is because now that we have our 3 congruent angles and our 3 congruent sides that are corresponding, we want to go ahead and finish the congruency statement. Now, when you're writing the congruency statement, there's actually 6 different ways you could write it in different orders, or actually just 3. Yeah, I think there's just 3. Because you could switch the last 2, you could switch the first 2, you can switch the first and the last. Anyway, I think there's just 3. But anyway, whatever you start out with, just make sure you keep the order the same on the other one. So triangle TUV. So TUV is going to be congruent to triangle what? So let's just put in order. T went with Y, okay? And then U went with X. And then W, of course, is going to go with the V. So triangle TUV goes with triangle YXW. Dyslexia is not a good issue to have when the order is very, very important. All right, moving on. Number 3. Which pair of polygons is congruent? Find the measures of the numbers angles. So on this one, I give you the congruency statement for the hexagon here. So you can probably visually tell which one goes with it, but that's okay. I want you to get in the habit of reading the statement. So G is the first one. That's going to go with the first one of A. So if A is 110, that means G, which is angle 1. Look over on the far right side over here. Measurement of angle 1 is going to be 110. E is the second to the last, which is going to go with K, the second to the last, which is the 2. Okay, so that's going to be 120. You can fill in the other 2 from number 4. Number 5, again, we're given the congruency statement. Now, these are pretty ambiguous. It's pretty difficult to tell which one's the smallest or the biggest angles. So that's why it's really important just to read the congruency statement. So, actually, you could totally cross that out. It's just extra information. You don't need it. Everything we need to know is all in that one congruency statement. Just read it. All right, list 3 pairs of congruent sides. So CA is going to be the first 2. So CA is going to correspond and be congruent to JS. So this would be JS. There we go. Get out of here. No, Charlie. Okay, there we go. AT is the last 2. That's going to go with SD. And then CT, the first and last, goes with JD, Jelly Donut. All right, name 3 pairs of congruent angles. So angle C, first one, goes with angle J, the first one. Angle A, the second one, goes with angle S. And then T, the last one, goes with D, the last one. And again, we didn't have to worry about any of this mess. We got all that information from this packed inside this one congruency statement. How lovely. Number 9, can you conclude the triangles are congruent? Now, at this point, for us to be able to conclude that the triangles are congruent, we have to say that all the sides and all the angles are congruent. Okay, so that's the definition of of being congruent. We'll be able to in later activities, hopefully that we can do in class. If not, we'll do it later, maybe if we get time. I don't know. This all really sucks, but anyway, we'll be able to prove it with just 3 sides or combinations of sides and angles, okay? Starting tomorrow, you'll see that. But for now, in order for it to be congruent, all the sides, corresponding sides have to be congruent, and all the corresponding angles have to be congruent as well. So is triangle GHJ and triangle IHJ, are they congruent? So first look at all the sides. We've got 1 and 1, 2 and 2. The only question we have is JH. Is JH the same length for both triangles? Well, if you look at it, those triangles are right next to each other, right? So whatever that length is for JH has to be the same length for the other triangle, right? So we will actually say that it is congruent. We're going to say that it's congruent to itself by the reflexive property. Remember the creepy baby photo with a French mustache? So that's the reflexive property. Things are congruent to themselves. Baby is congruent to baby. 3 is congruent to 3. And in this case, we're saying that the distance between JH is going to be equal to the distance between JH. In other words, those segments are congruent. So JH is congruent to itself by the reflexive property. Okay, just keep that one in mind because we're going to use it all the time. All right, the other thing, are all the angles the same? Well, obviously right angle is the same with the right angle. This one's a little bit harder. So if you look at this triangle, you see how these two sides are the same? What do we call triangles with 2 sides are the same? It's not scalene. It's not equilateral. What's the other one? It starts with an I. I know you're just yelling at the video right now. Isosceles, right? So what do we know about the base angles of isosceles triangles? Well, they are congruent, meaning if these sides are the same, then that means their opposite angles are the same as well. So this angle and this angle have to be the same. And now that we know 2 angles of the triangle, we know the third angles, by the third angles theorem, have to be congruent as well, because they all have to add up to 180. The top triangle has to add up to 180, and so does the bottom one. And so, for instance, if I know this is 90 and this is 40, right, and this is also 40, so 90 and 40 is 130, so what's left over? This angle would have to be 50 degrees. Well, so would this one, right, because it's the same 90 and the same 40. Get it? That's called the third angles theorem. All right, so we did reflexive property, third angles theorem, base angles of isosceles triangles. We're doing all kinds of things with these proofs, but it's good for you. If your brain hurts, that means it's a muscle and it's growing. Number 11, that's why I'm also doing these with you, because I know they're hard. All right, can you conclude that the triangles are congruent, meaning all the sides are incongruent? Oh, yeah, let's go back to this one. Are all the angles the same? Yes. Are all the sides the same? Yes. Remember with the reflexive. So yes, we can conclude. So our final answer on this one is just simply yes. All right, what about here? What do you notice about AB right off the bat? You're just going to focus in it. It is congruent to itself. Remember what that property is called? Not the creepy baby property, not the French baby property, not the top hat baby property with the gold chain with the G on it. No, it's called the reflexive property. I did draw the OGT gold chain on it. Inside joke, it'll come back later. So we have 1, 2, and 3. Good to go. We know this is a right angle, so the other one's a right angle. Base angles are always congruent. So what do we know about the angles on the top? Well, the angles on the top are going to be congruent, and the reason for that is the third angles theorem. So this one was reflexive property, and then we had third angles theorem, and then everything else is given to us. So all the angles are the same? Yep. All the corresponding sides are the same? Yes. So are they congruent? Yes, they are, because the angles and sides are all congruent. All right, number 12. What do you notice in blue? Parallel lines. Okay, so if these lines are parallel, then what do I know about angle F and angle J? Well, they're congruent because they are what kind of angles? Alternate interior angles. Remember that? So 2 parallel lines, or we think they're parallel. Well, they told us they're parallel because we got the little triangle symbols on them, or little chevrons. And then we have this angle here and this angle here. What kind of angles are those? Well, they're on the alternate side of the transversal, and they're both on the interior of the parallel lines. This is called alternate interior angles. Remember doing that? And what's special about them? They are, sure enough, congruent. So those angles are congruent. What do we know about the angles in the middle? Vertical, right? Vertical angles. Okay. And then if these two angles are the same, we know by the third angles theorem, this angle here, wherever it may be, there it is, and this angle down here has to be congruent as well. Now, on this one, we could use either alternate interior angles again, or we could use the third angles theorem. In case you're wondering. Okay, so all the sides are also congruent, so our answer on this one is yes. Number 13, we want to provide justifications. I feel like we're doing proofs because we are. Why is L and Q? Well, L and Q are going to be congruent angles because they told us they were. If we look at the diagram, they're already marked, so they're congruent. So our answer for that one would be given. We should change colors. I'm going to do purple. And then LMN, so LMN and QNP are basically the two N angles in the middle, and they're going to be congruent because they are vertical. So vertical, that's an A. And then angle M and angle P, well, if we know two angles are the same, we know the third angles have to be the same because of the third angles theorem. So again, third, oh, lovely handwriting, angles theorem. Okay, and then all the sides are all congruent. That was already given to us, so that was just given. And then the last statement is that the triangles are congruent. And this is just by the definition of congruent triangles. That'll work for me. So if they're congruent triangles, we know all the corresponding angles and sides are congruent. So that was just the final statement that we made there. Okay, good to go. Number 14, find the values of variables. Well, if this is 5x, the vertical angle is 5x as well. And then this angle is marked with 1 mark, 74. And this is also 1 mark, so that means that's also 74. And then we know the last angle, the third angle, which has to be the supplement of those two, is 3x plus 2. So then we know all these angles together have to add up to 180 degrees because it is a triangle, right? If I did a parallel line here, this one would be alternate interior with 74. This one would be alternate interior with 5x. So all together, those add up to 180. So add them all up, set them equal 180, just like we do with supplementary, like we did on Unit 1. You guys figured out how to do. First, that would be minor like terms. 5x and 3x is 8x. 2 and 74 is going to be 76. We can't add the 180 because it's on the opposite side of the equal sign. So we just move on down here. What in the world? What just happened? I don't know. Okay, pretend like you didn't see that. All right, combine your like terms. Subtract the 76 from both sides. We're left with 8x is 104. Divide by 8, leaving us with x is equal to 13. You know, algebra. Stuff we learned last year. But I'll help you with this year. Don't worry about it. All right, 16. We're given a congruency statement. We have angle B and angle G. Notice those are both the second one. So that means they're congruent. So we can set them equal to each other because they're congruency statement, they're corresponding parts, so they're good. So 3y is equal to y plus 50. Okay, and then we can't add the y's together because it's on the wrong side of the equal sign. So it's not 4y is equal to 50. We have to subtract the y from both sides. So we have 2y is equal to 50. Divide by 2, we get y is equal to 25. Last one I'm going to do with you. We're going to come under 30 minutes. I know the first one is always a longer one, and I'm spending a lot of time doing, like half the time has been spent doing homework, so I don't really feel bad for you. All right, number 20. We got two quadrilaterals, and looks like we can move the corresponding parts over here. I should have given you a congruency statement, but I didn't. So those parts are the same as there. That one's and those two are also the same, so we can move it over there. I don't think I made duplicates, so don't worry about it. All right, so then we have all these together. What do they add up to? Well, there's multiple ways to figure this out. One of the ways I like to do it, if we break a diagonal here, we have two triangles. This is 180 degrees. This is also 180 degrees. So if we add those two together, the total of the interior angles for a quadrilateral is going to be 360 degrees. Meaning we can add all of them together and they add up to 360 because there's two triangles in there. Kind of cool. We'll talk about more of that when we come back from Christmas. So combine your like terms. We have 9x plus 45 is equal to 360. Subtract the 45 from both sides. 9x is 315. Divide by 9, leaving us with x is equal to 35. And that, ladies and gentlemen, is it. If you guys have any questions, please let me know. I'll be out of town for like the first part because Thanksgiving, going down Stratford and helping out in the ranch and all the kinds of cool stuff we get to do out there. Redneck stuff, chopping down trees, running chainsaws, whatever, blowing stuff up like puppies. Yeah. Anyway, I'll miss you guys. I already miss you guys. You're super cool, even though I only met you for like 2 days. Try not to be like super sad about not seeing you guys for the rest of the semester, but don't really know. The other thing, just want to restate, make sure that you have all of your homework turned in, because if we don't come back in person, I can't base your grades based on the test. Instead, it's going to be reverted more back towards the homework. And so make sure you have all your homework turned in. So if you haven't done and you slacked off on the homework, you're going to have a wonderful Thanksgiving because I'm calling parents. So see you guys. Have a good one.